Alright, hi everyone. So today I'll be demoing a little circuit I've put together. And once I get it lined up, I'll show you too. Not quite as nice as it looks on the screen, but still you can see what's going on. So everyone at the back. And a few little hardware mods that I just stumbled across that I haven't really seen anywhere. So to start with, the one I'll show first is the one I'm cheating because I've left it plugged in so I don't plug it in wrong. Is just a replacement Raspberry Pi cobbler. So just using an old IDE cable, we can strip off a couple of wires, which helps with getting the orientation right. The main piece of advice I'd give for these is I did label the wires, but I took the labels off, thinking I had it all sorted. Leave labels of which pins which on your ribbons. And that gets us a nice little pin strip into the breadboard. So apart from that, now we'll go for power. So our old IDE power supplies, the venerable old floppy disk drive PowerPoint is very header pin friendly. And so just using 8 header pins, a pair of 2 and a 4, we can plug into that. And using the other half of our IDE cables, you can see all I've done is soldered a strip along each side, and you get a little mini breadboard out of that. So we'll plug the 5 volts into that, and using an old USB power supply, old micro B USB plug and more header pins. This is my mantra for the talk: header pins and shrink wrap make everything work. We can just plug into a power rail, and so just using one power point you can power pretty much as many Raspberry Pis as you'd like. I've had 3 going and a phone, and there's no worries about this not having fingers crossed. Yeah. Oh, no, 1 pin out. The dangers. All right. And the only other cable we'll need to know about on the power supply, and I've done some where I've soldered in a switch, but for a long time I just jabbed a wire in, is the green one there. We just need to short the green one to an earth, and that switches our external power on. The advantage of soldering a switch in is you've now actually got a power switch for your Raspberry Pi, which can be really handy when you're running out the door and want to switch everything off. So, hopefully this isn't where it ends.
Should one of us go in the fuse box?
Yeah, possibly.
How do you debug this configuration?
Yeah, usually pulling everything out and starting again is the best method. So we'll start that. And if I fiddle around for more than a few minutes, it actually runs without the Raspberry Pi now. And if the power supply doesn't work, I'm in trouble.
Yeah, plugged in?
Yeah. Is that in plugged in? Yeah. Actually, yeah, that's charging. Okay, I might have to give up the physical demo. Actually, let's chicken out and use a spare USB. Apart from here, I've had great success with that. But the advantage of using the power supply and the header pins is for working with a full-size breadboard. You get a really reliable power supply on your rails. And the only other thing I need to plug in is just a network so we can connect. And so now we've got the hardware connected up. We can get to the bit we're really interested in, the code. So, I'll just SSH. Oh, this is a terrible keyboard, so I'll do that a lot. I need to look at this. Just in case one of this doesn't work.
Spell those right.
PuZZleDuck.
TAU. Let's check my history.
Maybe you need to reboot the Pi with the nickel cable.
Yeah, it's worth a try. And in the meantime, I'll run one of the ones that doesn't require a plug-in. So let's have a look. So one of the things I wanted to be able to do was to be able to run this when I wasn't wasn't with my hardware. So this one will do well. And I'm using Maker. I've had to learn it for other reasons. But it is handy for running on the PC and the Raspberry Pi. Make run. Still got the sudo in there. No? Everything's going wrong. Alright, so this is a virtual ASCII version of the LED display. Whew, something went right. So I'll try SSHing in again. I've got the, yeah. No. I've just got a router plugged in under here. Other than that, there's nothing up my sleeve, unfortunately. I'll try pinging it.
Is there IP? Try the IP directly.
I have not had luck doing that, and I've always had luck with this. I'm trying to keep my script and it's not working.
I think this one might have to plug into the router, not directly to
Hmm? Yeah, it is plugged into a router under
okay.
here. Yeah, that is.
so that's
Yeah.
a different yellow cable that
Yeah, it is. There's magic smoke underneath, and the magic smoke seems to have escaped. But we'll have a look.
Powerboard hasn't lost its fuse or something.
Fingers crossed. But anyway, I'll show you the code before we have a look at the last little demo. So this was the original version as it was when I at the last meetup. So it just creates a stream, and for each calls the pulse function of that. At the moment, what I've now done is had it go through an abstract class. So this is just an abstract pin, does absolutely nothing but pass it on. And the GPIO pins implement that and just pass on the pulse and do a pause after each line. And the version I've just run on the desktop is, you can see it's called parallel ordered. So I was talking to my dad after I got this working in front of him, thankfully. Anyway, someone's seen it. And trying to explain why it's a good thing that that it's using functional programming and streams. And there were a couple of things that I thought, no, Dad's not going to find that cool. Oh, it's the hip music. No, he's not going to find that interesting. And I sort of thought, well, if it's written correctly functionally, I should be able to run it parallel, and the ordering won't get messed up. And so I ran it parallel, and can you guess what happened? It doesn't go well. So this is the problem I was going to leave it on, basically, is so I've realized that I'm using streams and lambdas, but at the real back end of it, you can see in that GPIO pin, here I'm doing a pulse and I'm doing a sleep. It's very iterative thinking, and just cramming it in a lambda doesn't make it a functional program. So if anyone's got any ideas of how to do sequential events in a functional sort of way, that's where I'm looking to take this next.
So just to go back, where's the calling code that's calling pulse pin?
Yep, that's in linear LED. So this, in our stream here, for each pin in the stream, pulse the pin.
Yeah. And so when you have a normal stream, it's fine, but you go to a parallel stream, and of course
then it goes askew. And parallel ordered works. That was the first one I showed. But parallel just by itself definitely doesn't. So my thoughts were along the lines of, well, maybe it should be based on a starting time, and each of them should have a triggered event for when it should start and finish. But I don't know if that's really
sequential. It's different. Like parallel, you don't care about the order. Sequential, you should be taking another approach.
Yeah, I'm almost thinking that that's actually working the spec.
That it should.
That's
Oh, it is. But I wouldn't mind. Like, it'd be handy if it could prepare the firing of the pins ahead of time. Like,
so you'd still have some sort of trigger or latch to make you still.
Because you can tell by the fact that in the previous one, we're at 4. So you can see that more than one processor are actually working. So there is some preparation it could be doing in the meantime.
I think what one thing that one way of looking at that might help be functional, but still do what you want it to do, is to have some sort of globally visible state, and have these things as independent views of a state of a common state machine with a common state event. So that you need some common viewpoint that all these parallel things can look at asynchronously.
yeah, so that's pretty much where I leave it. The only other, the more dramatic demonstration was going to be that these can actually be all in the same list. So it was going to flash the ASCII LEDs and then carry on to the physical LEDs, but we've had no luck with that, so I'll call it quits, and I'm glad I did the ASCII version. Always have a backup plan is the real lesson.
So we did film this at the last Milk JVM, so as soon as my computer comes out of hibernate, I'll show you the YouTube video that we filmed for those who haven't seen it. So
Oh, yeah.
the actual, the end goal actually was here.
And it's also all up PuZZleDucK.org, the last one under Duke here, Lambdas and LEDs. Yep, we're off the internet, but that's got all the instructions and setup I did. But yeah, and the code's online somewhere. That's all there as well. So yeah, thanks for your time.
So while I'm, how did you find actually getting into the Streams API? How long did you reckon it?
As I sort of say, like it's a lot easier to use than it is to think in that way.
Right.
Like, yeah, you know, very easy to take a for loop and replace it with a stream like that I had going last time, and almost nothing's changed on that in the couple of weeks. But yeah, it's still very iterative style
Sure.
of using streams.
Yeah.
But yeah.
Yeah,
But,
I think what most people do is for each is so easy to do, and then everyone just takes all their normal for column each. And so just go, okay, for each now I'm using lambdas, but then you're not changing.
Oh, and I got to use the ellipsis for setting up the pins.
Okay.
In the constructor, you can give the object type and 3 dots and the variable name, and it comes out as an array or as a list. Yeah. I'd never had an excuse to use it before, so
Yeah, yeah, it's pretty good shorthand. So let's find you. Sorry.
yeah, that's it.
Apologise for the sound.
Alright, so this is the Raspberry Pi workshop, and we've got this bit of LEDs running Java 8 and SE, and
Just started recording my stuff.
we've got Mr. PuZZleDucK. I actually don't know your real name.
Ben.
Okay.
But that does online.
And Ben's just showing compiling code, writing Java in Nano, and
Assuming I know what to install. Yeah, I had to upgrade the IDE by the end.
did you show Angela?
I was fiddling around with this one.
Okay, you gotta, yeah.
Yeah. Yeah.
That's pretty cool.
Yeah.
Still compile errors?
I'll go on that. Yep. Yeah, so it's only lambdas one way.
Cool.
But there's, yeah.
Yeah, I suppose it's only like a 1 gigahertz processor.
And I'm not very specific with my import statements, so that probably doesn't help. And unfortunately it has to run with sudo, but and breaks. It should start after a small delay.
Oh, fantastic. So that's with
No, we're meant to be ASCII characters on the end of it. This way is like the backwards is iteration, because I couldn't get it sorted before.
That's pretty cool.
So after the last month's workshop, shut up. You're gonna say that to me later on. So after last month's workshop, who got one lead going? And yeah, you know, how much effort did that take? You know, so we've got, you know, Ben over here has done the whole array.
That was the other thing I did leave off. I meant to say, you know, it also doesn't really the biggest thing is practice, practice, practice. I got like about 4 this size, of which about half of them have like LEDs that don't work on it. It took a few failures before I got the whole row of them.
Actually just soldered
Yeah.
up properly and
Yeah, and just learning to solder properly.
Microsurgery.
Yeah.
I've got a question.
Oh yeah.
Now we're requiring pseudo permissions to do like everything. Is that something to do with hardware access permissions?
Pretty much it seems to be. There's a little bit of move. You kind of can make it in a safer way, but really at some stage you've got to sudo or authorize the permissions at some stage. There are ways, like the way I've done it, I've got a makefile that'll create a schedule and run it every 2 minutes or so. And in that I've just got a script that's running the sudo command and given that script authorization to run sudo. So it means it doesn't have to actually ask for a password every time. But yeah, it still is there. Yeah.